Hello everybody and welcome to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, and step 3. And your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of steps in the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get with this one. All right, well, just looking at this, I noticed right away these squares, and they're getting big pretty rapidly. If you don't think about the border, we've got a 3 by 3, a 5 by 5, and that's a 7 by 7. So I guess this is going to be a 9 by 9 square here in step 4. Not 9 by 8, 9 by 9. And then what does this pattern do? It looks like it's every other. Oh, I see. It's really just the same 8 blocks. They just get spread out. So we got each corner and then the middle ones. So it's 3 on the sides, 1 each on the top and the bottom. So that's just 8 extra blocks. So this should be 9 times 9. That's 81 plus 8. That would be 89. So my prediction for step 4 is 89 squares. All right. So my guess here is this is going to be a quadratic because we've got these squares that are growing. And we could go ahead and analyze the numbers and sort that out, although I'm pretty confident. I think actually what I'm going to just do is try to approach this one from a visual reasoning standpoint instead of analyzing the numbers this time. You can go ahead and analyze the numbers if you'd like to, like we've done before, and you may arrive at the same result. But let's look at this. So we have let's just make a kind of a list here. We've got 3 squared plus 8, and that's in step 1. And then we've got 4 squared plus 8. Nope, we do not have 4 squared plus 8. We've got 5 squared plus 8, and then 7 squared plus 8. And we're predicting 9 squared plus 8 there. So those are our steps. And this is really a square that's twice, well, oh, I see. It's going up by 2 each time. So let's think about that. The side of the square is 3 and then 5 and then 7. So if you want to make an equation for just the side of the square, it would be 2x plus 1. And let me tell you how I arrived at that. The 2x, because it's growing by 2 every step, and then the plus 1 to make it work with step 1. So in step 1, this would be 2 times 1 plus 1. 2 times the step number plus 1, that's 3. Here in step 2 would be 2 times the step number 2, that's 4 plus 1 is 5. And in step 3, 2 times 3 is 6 plus 1 would be 7. So this little piece right here is going to give us the side of the square. Then to get the number of little squares inside that, we just have to square it, multiply the side by the side. So that's for the square part, and then we've got those 8 squares around the outside. So I think that's going to be our equation. Let's actually FOIL this out though. Let's see, so that'd be 4x squared, and then 2x and 2x, that's 4x, and then a plus 1. And then we've got our plus 8. So my equation then from this visual reasoning would be y equals 4x squared plus 4x plus 9. And in step 1, that would be 4 times 1 plus 4 times 1 plus 9. So that would be 17. And we've got 9, and the 8 are on the outside, so that is 17. And you could go on and test this with the other ones, but really it's the reasoning we used to create this. In step 2, you'd have 16 plus 8 plus 9. That is going to be the 33 that we have in step 2. Does that sound right? Well, double check that if you like, but I'm pretty sure this equation is going to be right. So I'm going to jot that down here. Y equals 4x squared plus 4x plus 9. Now, to calculate the number in step 43, we're just going to plug in 43 for x. So y equals 4 times 43 squared plus 4 times 43 plus 9. And let's see. Well, 43 squared is 1849. And 4 times 43 is going to be 172. And plus 9. And let's see, 4 times 1849, that's 7396. Plus the 172 plus the 9. I'm getting 75, 77. Double check that, but that's how many squares I think we're getting in step 43. So how did that one go for you? Did you see that kind of quadratic pattern? Did you approach this from a different direction than I approached it? Let me know. Thanks, everybody.